In section 3.7, we're going to be looking and talking about graphs of quadratic functions. And all of the ones that you're going to see in this lesson are starting from the format y equals x squared plus bx plus c. So no a, no coefficient in front of the squared term on any of these in this section. Also, all of them are going to have, it's a positive x squared, which means that yes, the shape of these quadratics is a parabola because all quadratics are going to be a parabola, but specifically because it's a plane x squared, they're all going to be opening up, because what makes a parabola open down is when the a is negative, and here they're all going to be positive. So we're going to be focusing on the graphs from two different perspectives, our two main key features, which are the vertex, which the vertex is always this center point that goes through the parabola's line of symmetry. And then we're also going to look at the X-intercepts, which would be the places or place where the graph crosses the x-axis. So I've written out steps for how we find these. And the vertex, there's two choices because, as you can see in the examples I've typed out in example 1, sometimes we're going to be given the equation in a standard form like this, and sometimes we're going to be given it in factored form like this. So this is for standard form. These are the 3 steps that you'll use to find the vertex if you're given the equation in standard form. If you are given factored form, then it's easier to use the second set of steps. So in standard form, the x-coordinate is going to be found by doing opposite of b over 2a. Now that only finds the x. We have to then plug in the x-coordinate to the equation so that we can find the y-coordinate. Don't forget when you do those things that you should be listing the vertex as an ordered pair. It's a point on the coordinate plane. When we have it in factored form, what we're going to do is find the x-intercepts first and then average those. Remember, average means to add them and divide by 2. So x-intercept 1 plus x-intercept 2 divided by 2 is going to give you your x-coordinate. And then just like we do in the standard form, once you have the x, you plug it in the equation to find the y. X-intercepts, we are always going to plug in 0 for y. We're going to get it factored, so obviously if it's in factored form already, that's done for you. Then we're just going to use that 0 product property that we talked about. We're going to set the factors equal to 0 so that we can solve for our x's, and then we need to write them as ordered pairs. So if you find 2 x-intercepts, the ordered pairs, the way we write them are x value comma 0, and then of course same on the other, because an x-intercept is on the x-axis, its y-coordinate should always be 0. All right, so let's take a look at some of these. In example 1a, we've got it in factored form, which means we're going to want to find the x-intercepts first and then use those to find the vertex. So we can plug in 0 for y, so 0 equals x plus 6 times x minus 2. 2 is factor, it's already factored for us. Step 3, set the factors equal to 0, so x plus 6 equals 0, x minus 2 equals 0, and then we're going to solve. So here, subtract 6 on both sides, x equals negative 6, and here we're going to add the 2. So final step, write them as ordered pairs. So x equals negative 6, so that means negative 6, 0. And then x equals 2 would be 2, 0. So these are my x-intercepts. Then I go to find my vertex. So I need to find the average of the x-intercepts. So that means I'm going to take negative 6 plus 2 and divide it by 2. Negative 6 plus 2 is negative 4. Negative 4 divided by 2 is negative 2. So the x-coordinate of my vertex then is going to be negative 2. So last thing to do, step 2 here, plug in that x-coordinate to the equation to find the y-coordinate. So I'm going to plug in negative 2 right to the equation. So negative 2 plus 6 times negative 2 minus 2. So this gives me negative 4 in my first parenthesis. Second parenthesis is also negative 4. So negative 4 times negative 4 is positive 16. And so then I'm done with that one. Looking at B, same idea, except this is a standard form, which means I can find my x-intercepts first or my vertex first. It doesn't matter. So I'm going to go ahead and do the vertex with these 3 steps since we haven't done those steps yet. So I'm going to do x-coordinate equals opposite of B divided by 2a. So remember, B is the coefficient of the linear term, and in all of the ones in this section our a is 1. So opposite of b would be opposite of negative 12, which is positive 12, divided by 2 times 1. So that's going to give me 6. So the x-coordinate of my vertex is 6. Then I'm going to plug it in to find the y-coordinate. So 6 squared minus 12 times 6 plus 20. So we can plug that all into the calculator. 6 squared is 36, and 12 times 6 gives us 72. So I have 36 minus 72 plus 20, which gives me negative 16. So that means that my vertex is at 6, negative 16. So x-intercepts, plug in 0 for y. Then I'm going to factor. So there is no GCF. I always look for that first. It's not a special case because this is a trinomial and 20 isn't a perfect square. So that means since it's a plain x squared, this is going to be chart factoring. So I'm looking for the factors of 20. And we want the sum to be negative 12. So that tells me it needs to be minus minus, those sign rules. So negative 1, negative 20, negative 2, negative 10, not divisible by 3, negative 4 with negative 5. And since I've come back around, I know that's it. So when I add all of those together, my sums are negative 21, negative 12, and negative 9. Negative 12 is what I wanted. So these are my winning factors. So it's going to be x minus 2 times x minus 10. And so then it's factored. Step 2 is done. So go ahead and set each factor equal to 0. And solve. Here, solve by adding 2. So x equals 2. And here, adding 10. X equals 10. Last step is to write them as pairs. So my x-intercepts over here are at 2, 0 and 10, 0. And there is my answer. All right, so now we're going to focus on problems where we actually have the graphs either as parts of the answers or as the problem itself. So example 2, which graph is defined by the function below. So I'm going to show you, 2 ways to do this. First, we can use exactly what we did in example 1 if we want. We can look at this, we can say, okay, it's in factored form. So if I set each of those factors equal to 0 and solve, notice they're the same factor, that means that my x-intercept, and there's only one of them, is at negative 4, 0. So actually, that right there is enough to make the right choice, because this x-intercept, you can see this is 5. This is at positive 4, 0. Choice B has two x-intercepts, which is not going to work. And choice C's x-intercept is at negative 4, 0. So I know that it's choice C without even going further. I picked this one on purpose. Whenever you have two factors that are the same, remembering that that means that the original standard form quadratic was a perfect square trinomial, those ones are always going to have just one x-intercept, which means that their vertex is going to lie on the x-axis. So neither of these ones, if we graph them, would do that because they have two x-intercepts. Their vertex is not on the x-axis. Now, the other way that you could do this is by actually going to Desmos and graphing it. So if you want to do that, you would go to Desmos, pull up a screen, and you just type in y equals, and then put the equation in exactly like it appeared, x plus 4 times x plus 4. Now notice I've got a much smaller window here, so if I zoom in and then drag it so I can see it better, you can see that I end up with that negative 4 x-intercept, so you could match it that way. All right, example 3, which is our last one. Which function best describes the graph below? So again, you have a couple choices for how you can do this. You can look at this and you can say, okay, this appears to be counting by 2 on the axis. So this is negative 2, 0, 2, 4, 6. This would be 8, and this is 6, so this would be negative 7, 0. So if it has those x-intercepts, that means that I had the opposite factors in my factorization, so x plus 7 times x plus 2, which means I can automatically eliminate this. It has the wrong signs. Those are minuses. It should be pluses if I want to get negative x-intercepts, and this one doesn't work. That one would have the same look as this in that it would have its vertex on the x-intercept with just one x-intercept. I could then multiply these out to see which of these gives me the right thing. So x times x is x squared, x times 2 is 2x, 7 times x is 7x, 7 times 2 is 14. And I see these give me 9x in the middle, and so D would be the correct choice. So again, that's a by hand method. You could also, just like I used Desmos on the last one, you could go to Desmos and type in each of these equations until you find the one that matches. So we found D here, x squared. So if I type that one in, y equals x squared. And to get the squared, you can either type the caret or go down here and use this guy. And then it was plus 9x plus 14. And then notice I've got an x-intercept at negative 2, 0. I've got an x-intercept at negative 7, 0. That matches what I had down here. So hopefully that gives you a couple choices. Make sure that you ask if you have questions or need help.